I appreciate this opportunity to talk about something that I'm generally excited about. This is something that I deal with nearly every single day, and it's a big component of my job. And I can go into the background a little bit in a second, but this is kind of what we're going to go over today. We'll talk about this background and then just kind of my general design strategy for making parts that you can remove from things. And then going over some of the analysis tools that I use to check for viability, and then going through some of the other little tricks that I do to make things work out for us. And then part design considerations, and that's just kind of a thought experiment. And then some other little things that may or may not be of value, but they're of value to me. So the first thing I always think about when I think about the background for what we do is that casting is a pretty efficient way to produce a part of a given shape and geometry, or hopefully in my industry produce a lot of parts. My experience is entirely within permanent mold aluminum casting. I hope some of these principles can be carried over to other metals or plastic injection or other forms of part production. What happens is 80 to 90% of the parts that we see from customers aren't quite ready for casting. They're just not, they wouldn't work, they drag out, they not function well for us. And so I have the opportunity to work closely with a lot of our customers in producing new designs or revising their designs that make their parts work for us and for them. And with that, I go through a lot of these same motions over and over again. And that really kind of inspired me to want to share and teach and hopefully impart some of my knowledge and assist others in making sound decisions for metal casting and other purposes. So that if you're not our customer, that's fine, but it's somebody else's customer, that somebody else will truly appreciate this effort. So one of the major things about casting is that we don't like straight 90-degree sides that are parallel to the direction of the pole. It creates problems where you can't actually remove the part from the mold despite all your best efforts, and it won't work. If you design with areas of undercut in mind, you'll have to get a chisel to get your part out, because it'll lock it in. And we always jump to the worst case of, well, if we have this undercut, we're not going to be able to make more than one. So yeah, that's the thing with undercuts is you can make exactly one part. Thick and thin sections, and it depends on your industry, it depends on your material, but in our case, in permanent mold aluminum, thin sections don't tend to do well, and that's just a flow issue. I know plastics, thicker sections are problematic, but so it's something to consider in design considerations, and that's something that you need to be aware of specific to your material. Parts need to have at least some kind of continuous parting line. It doesn't necessarily need to be planar or all in one flat row. We have some parts with some pretty funky, joggy parting lines, but it needs to be continuous all the way around so we can actually open the mold up and get your stuff out. Something else, the other two at the bottom, understanding where it's okay to have kind of a rough surface, where you need to have better surface quality, and understanding and informing your foundry, informing the people you're working with what your needs are for post-processing. Design strategy. It's a lot easier when you work the castability design in up front. A lot of times when I get parts, they come to me as step files or IGS files, and I can't get into the design history to fix them, so I have to work around them, and that actually caused me to develop a lot of little tricks that I use. But it's a lot easier when you have it up front. Once you figure out your base geometry, where you want your parting line to be, where you want your pole directions to be, and then draft accordingly. Keeping part thicknesses in mind helps, and also using all the analysis tools available in Solidworks to spot problems. They're really great at highlighting specific problems, and that's running a draft analysis is the very first thing I do for every part that comes across my screen. Once again, having an awareness of where your parting line should be in the design, early stages of design really are a great benefit. And Solidworks has an excellent parting line analysis tool to help kind of guide that, and I'll discuss that in a minute. Once you've developed your kind of base geometry and the other things in mind, then you can look at how to add or subtract a draft, and using all the fun tools like draft and move face and other, you want to massage we call it massaging the geometry to make it work for us. You got to keep in mind when you're dealing with draft is how your part dimensions are going to be. If you draft wrong, they're going to be in too little, or you're going to have thicker dimensions there. So it's something to keep in mind there. Once all those are done, then the other little fine details like fillets and chamfers and roundovers, that's when those go in best. I have to work around fillets an awful lot occasionally on some parts. And working around fillets and working around roundovers is probably the worst part of that. Probably the most important thing I think about design strategy is definitely keeping the communication or collaboration open with the foundry. I have developed some great relationships with some of our customers just because they're really on top of keeping me in the loop on what they're thinking for design change. I can come up with a design change and get that back to them, and we usually have a conversation about it. And it's really great to feel like more than just a service provider, but I'm actually collaborating on the next new hotness that's coming out. And they're great relationships that I actually really treasure. So I have here, this is one of my screens in SolidWorks, is I have all of my analysis tools grouped up together like that. And the four major ones that I use are the draft analysis and undercut tools. I use the thickness analysis when I really need a detailed view, and parting line analysis when I can't quite see it. That's where it comes into play. So draft analysis is a great tool, and it shows the draft angles of all of our surfaces relative to the direction of pull. The way it was described to me, if the surface lights up green, you're okay. If the surface lights up red, you're probably okay. And yellow is when you run into difficulty. And so, switching around. So let me bring up the model to work with. So this is one of our parts from a customer. In our industry, permanent mold, 2 degrees of draft is our requested minimum. It just doesn't work with less than 2 degrees of draft. At 3 degrees of draft, we really like what we see. 5 degrees is probably the best, but 2 degrees at least. So as an example here, most of that part is ready to go. And in this particular case, the yellow parts are going to be machined. So this is representative of the finished machine part, and it was a simple matter of just adding draft onto those spots. But another feature within SolidWorks is the face classification, where it actually breaks it down by a number of faces, and you can do those individually and just isolate where the problems are. Undercut analysis. This is just a little stupid widget I threw up to really demonstrate undercut analysis. I don't have a model available to really look at it, but red is bad. In this case, in the undercut analysis, red is bad, and that's the one that's going to tell you absolutely that you're only going to make one part ever. And in the same detail, there's face classification. You can isolate the individual colors and figure out where exactly your problems are, and hopefully come to a resolution of how to fix them. Thickness analysis is a really cool, really detailed tool, and you can return a report that is just really lengthy, and it can break everything down for you. I don't use it as much as the other two, just because in the case, for us in our case, we have kind of a given minimum thickness, and A lot of the times that's easy to see. But yeah, you can fiddle with the settings to get any kind of information out of the thickness analysis that you want. And in this case, of this same part, it obviously gets thinner at the top. Another fun tool, and this is not nearly as sexy as the thickness analysis, but we actually use just the cross section. And what we'll actually do is just take it and sweep it in and out and try to imagine all the angles and see where the thin problems are, the thick problems are. So it's really basic, it's really easy, it's not nearly as cool, but it's there, it's a tool that we use, and it works. Parting line analysis. Now this is one that it can propose your parting line, and if you actually leave the tool on, the parting line will dynamically change as you design and work on the part. If there's a really obvious parting line, then it'll follow it and you can't even see it, but when you don't really have something in mind, then it'll show a nice purple line that will wrap all around the part. Occasionally you run into problems where it'll make a really weird, wavy line, then at that point you really have to make some decisions and focus on what you want to get out of the parting line. Now I'm going to break into the design tools, the tools that I use every day to do my job better, to add draft, to make parts work out for me. Probably the first one, the one that I got most excited about when I learned about it, was split line, and where you can break a face into multiple faces. As an example, I have what I'm calling the unsettling egg. So I drew this up just kind of messing around one day, and I found it really unsettling because normally I leave all the view lines on. I couldn't really see any lines on this, and it was just really disturbing to have this beautiful egg shape turning around in it. I got a little worried. But with split line, you can take it and break it up into however many faces you need, and then from there you can figure out parting line, selecting a plane or a pole direction. And you wouldn't be able to see it, but there are parting line would be right along that line right there. Split line is really cool. It's got a lot of little sub options into it. You can project, you can draw a line somewhere out in space and just wrap that line around your face, and it'll break the line up exactly how you break the face up exactly the way you need it to. In a lot of cases, when we have just straight flat split lines, we usually put those along a plane, front plane, or the top plane, and it works well for us. But it's definitely worth messing around with and helping you figure out how to get your faces to cooperate. Probably the most powerful and expansive tool is the draft tool. There's a lot about the draft tool that I'm still messing with and figuring out. When something doesn't work, I usually can go back and fiddle with more settings and try something else with the draft tool, and it'll come up with a solution for me. It's really useful when you have faces that don't need further machining, because it depends on what algorithm is running, whether it subtracts draft or adds draft. But if those are not geometrically important, if they're not dimensionally important surfaces, then draft is the way to go, because you don't really need to brush up on trig. You don't need to figure out how much you added or subtracted based on this angle, because that does affect those dimensions in that way. My new favorite tool is actually move face, and it's something that I've really come to appreciate in the last couple of months. But move face just kind of does what I needed to do without fail. Prior to learning about whatever resource it is, if I needed to add material to, you can't see me pointing at this, so we're going to try it differently. If I needed to add material to that face, I would have made some kind of extrusion and do all these other things and make some cuts. But with move face, it's a simple Simple as grabbing the face and then scooching it up or down. And it takes your design intent with the, let me actually demonstrate how cool it is. It takes all your other design intent with it. So we can see that this face right here is red and ready to go. And then there's really there's a fillet that angles up into it. But with the power of move face, we can bring that up, and all those same features are still there. And there are no issues back here. There's no other issues. It's a pretty cool feature. It just does exactly what I needed to when I needed to. I call it my mind reader tool. Extrude draft. There's a little button whenever in your extrusion menu where you can specify a draft, and it'll actually extrude up based on the angle you specified. So I drew a shape at one point. It reminded me like a cool Dracula coffin, and so I just decided to run with it. So turn the scan way up. I managed to get 13 degrees on that one and 5 degrees on that one. And that's easily changed with turning on or off the draft function. It keeps the design tree a little bit nicer. It doesn't require a second draft step in the design tree if that's important by keeping your design tree tight. I got some other ways to add drafts, and these are the ones that get really kind of out there and required a lot of creative thinking on my part. You can sweep a triangular profile along a face if it makes sense to you to do that. You can actually lock between two triangular profiles, and that surprisingly comes up a lot with me. And much more mundane, once again a lot less sexy, is just when you're drawing the ball, just put the right draft angle in there. Demonstration. So this is similar to a part that we worked on last year. And let's show you the draft analysis. So there's no draft anywhere on here, and we need there to be draft. So I took this entire upper edge, turned it into a single sketch, and then just swept a little profile like that all the way around the outside of it to not only create draft, but also establish a parting line. So that we run the draft analysis on it, it lines up perfectly 3 degrees on either side. And
question?
Yeah.
If it's three degrees on both sides, why was one red and the other green?
It's relative to the pole direction. So let me go back and show you that. So it assumes that if you're pulling it that way, or rather, once again you can't see my hand, but pulling it apart, the interface between green and red basically represents the parting line.
Okay.
If I were to put the parting line down at the bottom edge, then it would all be green and it would all slope one direction. But I did a cut that went down and then back in to help define a parting line in the midsection of it. And that's all just kind of a preference. At our plant, we don't like to do just kind of one-sided castings.
Oh, okay. It's not indicating that the draft is okay. It's just indicating the two halves of the mold.
Yeah.
Okay.
Yeah, and in those two halves, they will probably work out. In our industry, in our plant, we actually don't like to make basically one-sided molds where you just have a flat plate running on something inside there. partially because on the foundry pour line we use refractory paint to make kind of a non-stick coating, and if anything else we will put a little chamfer or something on the bottom edge of a part just so it'll leave enough of a line on the other side of the mold to help identify where the mold's going to land, and so we can paint it along that, and it's just kind of a convenience thing for us, and it makes for a kind of sharper looking part that doesn't have a sharp on it. So this one is kind of esoteric and kind of out there, so just bear with me and hope you'll be able to understand what I'm getting at. So this is a part that was similar to a part we made last year, and it had this kind of weird central multi-plane little section to it, and we needed to draft this face a certain way. This face. And I completely out of ideas on how to do it effectively. I figured out I could draw a triangle over here and a triangle over there and just loft them together and get the angle that I needed. Now it doesn't make for a perfectly clean, crisp 3-degree or 2-degree angle. I had to kind of budget a little bit, but it worked out. It was simple and it didn't cause me that much headache. So just a 3-degree triangle over there. And then you can do a little 3-degree triangle there. And it made for a graphic surface. And I use the edges as guidelines, guide curves to help drive it nice and straight. And the result gives us not 3, but more than 2. The average draft angle is around 2.87, which is plenty fine for what we're doing. This is another example where you can sweep. In this case, I stopped it short right there. I didn't wrap all the way around. But, I don't know, it was just kind of fun. And what was nice about it, this part was symmetrical, so I was able to only had to do it once with a little complication, and just mirror it over on itself. So yeah, and once again, less exciting, less cool, but just make sure you put draft angles into your sketches when you're revolving or other operations like that. This is kind of one of the final things to talk about in your design is thinking about how it'll actually look in the negative. We've had parts come in that checked out perfectly fine in the draft analysis and in the undercut analysis, but in making them, we would have had to machine undercut into the mold. It's really weird. We have to think in the negative. We have to look at the part and think what the negative of that part would be, or the inverse of that part, and go from there. Outside edges of parts will become inside edges in the mold cavity, and so if you need a sharp, crisp outside edge, it's going to be done with difficulty because that has to be cut with a tool on the inside of the mold. And once again, that's just a permanent mold thing. It's different in different types of castings, so it's just something to be aware of and something to think about. It's beneficial to keep track of the faces that would need to be machined or those faces that are dimensionally critical. We have some customers that do us a big favor and they actually highlight those faces or make them a different color so they stand out, so we can know that, okay, we need to add stock on here, we need to make sure that this doesn't get touched, or we need to make sure that everything lines up per that. And that's just a design consideration, and that's something that, once again, discussed with the foundry. Part of one of the taglines for this class was just keeping all this in mind can really improve your relationship with your foundry, and like I say, that's absolutely the case. And I have developed relationships with customers that do these things, and it's really, really enjoying work with them. So So it's kind of a bonus thing. This comes up a lot in our office, is how to handle the data on this when you're working with a casting configuration or a machine configuration or both. How does this handle that? It's a good application for multiple configurations, if that makes sense for your data management, if it makes sense for your Foundry. We've done it both ways, where we have them as multiple configurations or even multiple parts. In our office, we like to use multi-body parts. So I'll take the machine drawing or the machine model and then insert it as its own body, or copy the body into itself and map it over itself, and then just constantly be working on two bodies that are occupying the same space, and make the necessary changes and apply those things to the casting body. And then at the end of the operation, split them out into individual part files that are controlled by one part file, one master file, and we can get our information for machining out of it, we can get our information for casting out of it. If we need to make changes to just the casting model, we can do that and have it not affect anything else upstream. And it's taking some getting used to and taking some real thought on how to make it work well for us, but we're about there, and it's pretty beneficial. So that's something to think about, is also how you're going to manage the data. I got some ideas for you. It also allows for, in the multi-body part thing, it allows for kind of real-time overlay, where you can overlay and make transparent one file, one part over the other, and so you can see what's getting machined off or what's getting added, where the holes are going, and yeah, it works well.